Hi and thanks for watching. This is part 2 of a Flownex mining applications video in which I'll be showing you a few more examples of how Flownex can be used to simulate thermal hydraulic systems that are often found in the mining industry. In part 1 I briefly mentioned some of the systems that can be modeled using Flownex Simulation Environment, such as mining ventilation, compressed air networks, water reticulation systems, and slurry systems. The first example I'm going to show you in this video is of a multi-stage compressor that may be used to power pneumatic mining machinery. Here you can see a schematic of the compressor, which is comprised of 5 stages that are connected by intercoolers. In this model we will be adjusting the compressor inlet guide vane angle in order to achieve a desired compressed air mass flow rate and outlet pressure. If we look at the actual Flownex network, you can see that we're able to plot the performance curves of each compressor stage and view our operation point. We're also able to calculate the heat load of each intercooler based on a fixed temperature and report the results onto the drawing canvas. While running a transient simulation, the inlet boundary conditions, namely the pressure and temperature, can be varied. In addition, the outlet conditions can also be adjusted to achieve a desired source pressure or mass flow rate of compressed air. We are also able to calculate the total input power. This is done by linking the result data of each compressor stage to a Flownex Excel component, where calculations can be performed in a spreadsheet. This model also incorporates the Flownex script component, which can be used when a network requires user customization using a mathematical interpretation, and a PID controller component. The script and PID component are used in conjunction to calculate the required guide vane angle based on the outlet pressure set point during the simulation. The second example is of a water hammer analysis. Due to the nature of mine water reticulation systems, they are susceptible to pressure surges. In this example, we are pumping water to an elevation of 60 meters, and we are interested in investigating the pressure surge at bend locations due to the pump tripping. If I start to run the transient simulation and trip the pump after a few seconds, we can see that the pressure remains constant initially at the bend locations, and once the pump is tripped, we have a pressure drop. And in a few moments we will see the shock wave start to develop as a result of the water hammer effect. Standpipes have also been modeled at these locations in order to mitigate the effect of water hammer. If I activate the standpipes, we can see that they have an effect on the amplitude of the shock wave and somewhat alleviate the pressure surge. Flownex has powerful design and optimization tools that can be used to optimize systems and thus minimize cost and optimize efficiency. The Flownex optimization tool can be used to maximize or minimize parameters by varying other variables in the system. Because of the large pumping costs associated with mine water reticulation systems, it would be beneficial to, for example, be able to determine the optimum pipe diameter for the lowest possible pump operation cost. The Flownex optimizer has also been refined for pump scheduling, this allowing the user to optimize the system energy consumption by means of scheduling the load during low peak hours. If you are interested in learning more about Flownex Simulation Environment, email, call, or visit the website and set up a discussion with our technical staff at PADT. mine